What's the next question? Derive the expression for the current in a straight long wire. Okay, but using Biot-Savart's law. Using Biot-Savart's law. So students, here we consider what one wire having infinitely long. We don't know the length, but I consider the what small length L. Through that wire, current is flowing I. Okay, so L is what length of wire. We limited that wire. I is a current in the wire. And what exactly we have to do? We have to find out the expression in the current, no? Expression for the current. So initially we consider one point P, which is at a distance capital R, okay, from the wire. But Biot-Savart's law will consider what small element of that wire. So here we consider very small element. Okay, here we consider very small element. DL, DL, okay, DL. So let me rub this again if it is not visible. DL. Okay. So this small element DL makes an angle of, if I join this DL and this P, so this DL small element जो DL है small element, it is at the distance R. It is at the distance R. Okay. Don't say R bar. I am not going to consider this vector quantity. It is at a distance R. An angle between DL and this particular joint. That is what this is the direction of what we will say this line. So angle is what? Suppose theta. Okay. And this will say this is direction of B also. Suppose इसको मैं बोलता हूँ this is direction of DB. Okay, DB. So students, according to Biot-Savart's law, what it states that dB is given by, what is dB? What do you know the formula? Mu naught upon 4 pi. Okay, अभी मैंने prove किया था. Okay, IDL sin theta. Okay, upon what? R square. Agree? But students, here, what exactly I am going to do? The thing is what? I have to find out the total magnetic induction. So what I will do, you will find this is upper part, upper half of this point P, and there is a lower part of the point P also. But I can consider what lower part also. The total magnetic induction is given by twice of integration of dB. Twice of integration of dB. Remember this. Okay. Twice of integration of dB. So students, what I am going to do now. Okay. So students, here I will put a value. Integration of dB. What is dB? dB we have mu naught upon 4 pi IDL sin theta, okay, upon what? R square. Okay, students. So students, what you can take common? Mu naught upon 4 pi is constant. 2 mu naught upon 4 pi I took the constant. I also I took the constant. Okay, DL also I kept outside. Okay, so now remaining terms are what? Integration of what? Sin theta upon R square. Okay. DL also I will keep inside because it's a changing wire. No? Okay. Now students, I have to think about sin theta. Will you know sin theta is what? Equal to sin pi minus theta. It's a formula for sin theta. Sin theta is what? Sin pi minus theta. What is sin pi minus theta? Sin theta. Why I have written like this? You know? Because this is theta, this is straight angle. So this angle is what? Pi minus theta. And this is 90 degree. What is sine? Opposite upon hypotenuse. Opposite upon hypotenuse. Okay? Opposite upon hypotenuse. So what I will write here? Sin pi minus theta is what? Opposite side क्या है? Capital R and hypotenuse is what? Small r. Okay? Now, what exactly we are going to solve? Students, will you observe one more relation between L, R and capital R? L, R and capital R. What is the relation? Pythagoras theorem. R square equals to what? Small L square plus R square. Okay. So students, I am going to replace this sin theta and R square by this particular quantity. Okay. So what will be? Consider here B is 2 1 the 2 to the 5, 2 to the 4. So mu naught upon 2 pi I. I will keep this DL outside. चलो ठीक है. Integration of sin theta की value is what? R upon R. R upon what? R. Okay. So that R upon R and this R square become what? R cube. And in that R cube, what I will put? Value of R. What is value of R? Under root of L square plus R square. So here I will write L square plus R square. Root means what? Raised to 3 by 2. Okay. Understood, students? And here DL I will keep outside because it's with respect to that L. So now what will happen here, students? Simple last step. Mu naught upon 2 pi I. Don't worry, I will explain again. If you are unable to understand, I will explain again. Don't worry. R is constant, so integration of 1 upon L square plus R square raised to 3 by 2 with respect to L. Students, since this length of the wire is infinitely long, that's why I will take the integration from 0 to infinity. Okay, I have to introduce 0 to infinity at the end. You have to take the integration from 0 to what? Infinity. 0 to infinity. Okay, and if I solve this integration, students, final formula you have to remember. इसका formula आपको बताना है मुझे. The formula is what? Mu naught upon 2 pi तो आ गया I R. And formula is, of this integration 1 upon R square. When Shiva sir will teach you different integration, you will understand 1 upon R square क्यों आया. So only remember this integration 1 upon R square. This R get cancelled. What is the final answer? Mu naught upon 2 pi I upon R. So this is what? Formula for magnetic induction. So now you are asking, sir, you said what is in the question? Find the expression for current. So you can find the expression for the current again. You can find the expression for current by shifting these particular terms in the left hand side. Don't worry, sir. I will explain it again. Don't worry. Hope so you understood. Again, I will explain. Okay.